Hi, I'm John Yarbrough with the California Department of Water Resources. Since we were not able to have an in-person meeting with the ad hoc group for our fourth meeting following the DWR-IRB meeting, we've decided to instead videotape, record the different presentations that we would have provided, and then to make those available to the ad hoc group and to the members of the community. The four different presentations that we're planning on going over today. First, we have Dan Wade, who is the co-chair of the IRB. He's going to be presenting the summary of his report that came out of the fourth DWR-IRB meeting. This is going to be followed by Les Harder doing a presentation on the Level 2 risk assessment and how that process interacts with the CNA process. Next, we're going to have Dave Rennie is going to provide a presentation on the State Water Project Asset Management Program. And this was not a presentation that was provided to the IRB, but we think this is an important context for the ad hoc committee to have, as well as members of the community. This is how the State Water Project looks at its entire system and then prioritizes projects that it needs to complete, like projects that might come out of the CNA process. Finally, David Ford is going to talk about the evaluation criteria for the CNA process. Before handing it over to Dan Wade, I'd like to go over the agenda that was used at the last meeting between DWR and the IRB. During that last meeting, we provided an update on the Level 2 risk assessment, also provided an update on the needs, objectives, considerations, and constraints development, so the development of those different aspects of each task. Next, provided a presentation on the evaluation criteria and the process for using that criteria. We provided an update on Task 4, the low-level outlet analysis, and then we went through the final report outline and additionally the task level report outlines with the IRB. Finally, we went through the comment log and looked through new IRB recommendations as well as the IRB's comments on DWR's efforts to date on past recommendations. During the second day, then the IRB deliberated and then provided their report, the report that Dan Wade will be summarizing here next. So thank you, and with that I will turn it over to Dan Wade.
Hi, I'm Dan Wade. I'm with the Independent Review Board for the Oroville Dam Safety Comprehensive Needs Assessment, and I'm here to report on meeting number 4, which was held March 14th and 15th of 2019.
Text IRB Memorandum number 4.
Just want to remind folks who the Independent Review Board members are for this study.
Text IRB Members.
We have Elizabeth or Betty Andrews with Environmental Science Associates, Dr. Lelio Mejia with Geosyntec Consultants, Bruce Muller, formerly with the U.S. Bureau of Reclamation and now an independent consultant, and he's the chair of the board, Paul Schweiger with Gannett Fleming, and myself, Daniel Wade with the San Francisco Public Utilities Commission.
Text Past Recommendations.
So what I'd like to start out with is just to review the status of our comment log from the past 3 meetings.
Text Status Descriptions.
And as a reminder, we have status descriptions in the comment log that have been defined to help folks follow the status of each comment that's been made. And so we have these categories, including under consideration, where the project team is considering the recommendation but hasn't necessarily committed to if or how the recommendation will be addressed. We have a planned status label where the Independent Review Board has accepted the project team's response and an appropriate action is planned, and we know that that's coming. We have a status label called In Progress where the Independent Review Board does see evidence of the planned actions underway. Then we have a closed status where the Independent Review Board has reviewed and confirmed that the project team's planned action has been completed and adequately addressed. And then we do have a not adopted category where the project team didn't adopt the recommendation and has provided an explanation. And there, in at least one case, we do have a recommendation that's been superseded.
Text Comment Log.
And so looking at the last 3 meetings, you can see that in the first meeting there were quite a few recommendations, 22 recommendations, and you can see the status of each recommendation there listed in the column. We have 4 that we know are planned, 8 that we've confirmed are in progress, and we've been able to close out 9 where the project team has responded and the Independent Review Board has confirmed that the item should be closed. And that first meeting did have one superseded recommendation. And then you can see the statuses for meetings 2 and 3 likewise. And you can see that over time there's less recommendations, which really shows that the team and the independent review board are getting closer in terms of expectations for how the study's been conducted and what the outcomes will be.
Report number 4.
I should say also that for the report that I'm giving today, the independent review board only has 4 recommendations, so much fewer recommendations than in the previous meetings. So now moving into report number 4, as is typical in each one of these meetings, DWR has asked the independent review board questions that we responded to after a full day of briefings, and then we gave a briefing to the project team prior to this briefing today. And so the first question that was asked by DWR for report number 4 was, does the independent review board have any recommendations or comments on the Part 12D Level 2 briefing? And this was a briefing that was given by the project team on the status of the independent review done through the FERC Part 12 process. And the IRB's comments are the following. Number 1, that there is an unprecedented level of effort with both national and international experts taking place in this Part 12D Level 2 briefing. And as a result, it's taking longer than was originally planned, but we're not surprised by that, and we see that it's a very robust process. We do agree strongly with DWR's decision to conduct parallel preliminary risk assessment for baseline conditions, and this will avoid delay. Originally, the project was lined up such that the level 2 risk assessment would be done in time for the comprehensive needs assessment project team to use those results without any delay. And because this process is taking longer, I think the team has wisely made the decision to conduct a parallel analysis so that the CNA can move forward without any delay. And we observe as the IRB that both analyses are based on the same factual information. Many of the people that are involved in the level 2 risk analysis are also involved in the CNA. The CNA is broader in scope than the Part 12D level 2 risk analysis, and it is appropriate and necessary for the CNA. And so the CNA team would need to do more than what's being done as part of the Part 12D process anyways, and so it makes sense that they would go forward with this parallel analysis at this time. We do caution, however, that it's important to think ahead on a strategy for addressing any differences that may be an outcome from doing these parallel analyses, and I'll talk more about that in just a moment. We think the risk is low, and we do feel strongly that the parallel analysis should go forward, but we do want to just strongly urge the team to think about how to address differences if they come along. And so the second question that was asked by DWR was, does the independent review board have any recommendations or comments on the needs, the objectives, the considerations, and the constraints that were set out in the project from the beginning? And those have been kind of a work in progress, and the IRB was very pleased to see that at this meeting we saw very clear and consistent need statements and project objectives, and we really felt like the team heard our comments from previous meetings and responded very proactively, and the IRB was very pleased to see that. We do see now that there are very clear distinctions between project objectives and project considerations. And we agree with using the DWR asset management framework as the basis for comparing alternatives. We think that will allow all stakeholders, both internal and external, to be able to view the information and the outcomes of this study in a consistent manner with other within the asset management framework that DWR has employed. We did make a recommendation, and the team has adopted it, to change the term project objectives to plan formulation principles, and that was to really avoid confusion with task objectives as opposed to project objectives. And so there was some terminology discussion in the meeting, and the team has adopted those. And so the third question from DWR was, does the Independent Review Board have any recommendations or comments on the evaluation criteria and process? And our response to that is essentially that the DWR asset management framework is considered appropriate for evaluating measures and alternatives within the bounds of the comprehensive needs assessment. We fully recognize that there are other stakeholder issues that need to be considered before final decisions are made on implementation of alternative plans, but that's a decision process that we understand will be employed by DWR leadership after the CNA is complete. And so we fully endorse the framework that's being used for the CNA process and feel that it's very appropriate. The Independent Review Board confirmed the process for formulating and screening the measures and alternatives. We're very glad to see a robust process presented, and we endorse that process and look forward to seeing the results that come out of it. Each failure mode brought forward will be evaluated over a range of conditions to help assess risk for more extreme and more likely events. Now, this is very important because if we just look at the extreme events, we could be missing events that are going to happen more often and could have very serious consequences. And so it's important to look at the range of conditions over which these measures will be tested. And we do recommend development of a clear strategy to check the Comprehensive Needs Assessment Preliminary Risk Assessment for consistency with a Level 2 risk assessment results prior to completion of the Comprehensive Needs Assessment study. And so this is one of our 4 recommendations, that a clear strategy be developed in case there's any differences that need to be reconciled at the end, and how will the CNA be adjusted as appropriate if there's any differences. The fourth question was, does the Independent Review Board have any recommendations or comments on the Task 4 update? We feel that DWR has appropriately documented a basis for considering the Hyatt power plant to be available for releases if needed for lowering the reservoir. The task team has made very good and substantial progress in developing the necessary information for the analyses that need to be performed. We were very glad to see the progress that's been made, and we look forward to seeing the progress of the other task teams as well at the future meetings. The Independent Review Board encourages DWR to begin developing the documentation for the background sections of the report. It's going to be a monumental effort to put all of the task reports together as well as the final report together. And to the extent that task teams can start doing some of the background work now, putting the data together, summarizing sections, and really setting themselves up for success towards the end, we would encourage that to happen. The fifth question is, does the Independent Review Board have any recommendations or comments on the task level report outline? This was the first time that we saw this outline. We had seen the master report outline previously, and we really do feel that it's a comprehensive outline and it's well organized. We agree with the emphasis on providing context and background information throughout the report, including summaries of existing conditions, summaries of previous investigations, and summaries of assumptions made to complete task efforts. And so, again, we think that a lot of these things can be done early as task teams are working toward the final report. The sixth question is, does the Independent Review Board have any recommendations or comments on the final report outline? We had seen this report outline in a previous meeting, and we saw an updated version this time. And we really do want to commend DWR for engaging a professional report writer to develop the reports for this study. It's a comprehensive outline. And we feel that it's very appropriate. They did incorporate our recommendations that were made in the last meeting. We do recommend that DWR would consider preparation of a parallel final report without critical energy infrastructure information that, as part of that report, to avoid the need for redaction of the final report for public release. And so this is an effort that we feel would pay dividends over the long term, and we would recommend that be considered. And the seventh question is, does the Independent Review Board have any recommendations or comments on the Comments Log? And we reviewed the status of that at the beginning of this presentation, and I really have no further comment on that at this time. And then the final question is, does the Independent Review Board have any other recommendations or comments? We talked about looking forward to the next meeting that's going to be held in August of 2019. And we did make some suggestions for topics that we would look forward to seeing at that meeting. Number one, we look forward to seeing results from the Comprehensive Needs Assessment Preliminary Semi-Quantitative Risk Assessment that's being done in parallel with the Part 12D Level 2 Risk Assessment. And so we'll look forward to seeing the results of that in August. And then we look forward to seeing progress draft reports for the various tasks, including identification of risk reduction measures, identification of measures screened out from further consideration, progress in completing those portions of the task reports, providing process and background information. And so, again, the earlier task teams can work on that. I think they'll be setting themselves up for success at the end of the project. And just as a concluding comment, the IRB was very pleased to see the progress that the team is making, and we feel that the team is well positioned to have a successful project with the work that's been done to date. And so we look forward to seeing the work that's upcoming in August and in the future meetings. Thank you.
Good morning. My name's Les Harder. I'm with HDR Engineering, representing the Department of Water Resources. I'm here today to give you an update on the Level 2 risk analysis that's being conducted for the department on Oroville Dam.
Presentation outline.
Generally, the outline I plan to do on the presentation is give you a background on the FERC Part 12D 5-year review process by an independent consultant, introduce you to the thought of a potential failure mode analysis, talk about the Congressional mandate for an independent Level 2 risk analysis, and then give you an overview of the ongoing Level 2 risk analyses that are being conducted. Talk about the organization, leadership, participants, the general approach and methods, and the status and accomplishments to date, and talk a little bit about a revised schedule that we have.
Text. Background.
So first, a bit of background. The FERC Part 12D 5-year independent consultant review has been in effect since 1965. It fulfills Title 18, Part 12, Subpart D of the Code of Federal Regulations for high hazard dams. It also fulfills the requirement for an independent safety review pursuant to the State Water Code, which requires that DWR retain an independent director's safety review on a 5-year cycle as well. The current Part 12D review is the 10th such 5-year review for Oroville Dam and appurtenances. That means it's been going on for 50 years. DWR has retained 2 independent engineering consultants and 1 certified engineering geologist to serve on the current 10th Part 12D review. And the 3 members of the independent consultant are Dr. Lelio Mejia from Geosyntec Consultants. He's also a member of the Independent Review Board. Dr. David Bowles of RAC Engineers and Economists. He's Professor Emeritus of Utah State and an internationally recognized expert on risk. And Drew Kennedy, who's a local engineering geologist with Sage Engineers. So a bit more on background. The Part 12D independent consultant every 5 years shall do these things: review relevant reports on the safety of the dam, perform a physical field inspection of the project works, shall review and assess relevant performance data, and evaluate the following things: the adequacy of spillway and relevant hydrologic data, structural adequacy and stability of structures and all credible loadings, history of performance, and quality and adequacy of maintenance. This is directly out of the Code of Federal Regulations. The independent consultant shall issue a report, and the report has to have these things. It has to have monitoring information and data, including drawings showing the locations of the instrumentation. Analyses by the independent consultant, analyses of safety of the project works, maintenance and methods of operation, implications of changes in information or analyses since the prior report, adequacy of existing monitoring instruments, periodic observation programs, and other methods of monitoring project works. The report shall make recommendations, including recommendations on the following: any corrective measures needed for the structures, maintenance, surveillance, or methods of operation, a suggested reasonable time to carry out each of these corrective measures, and any new or additional monitoring instruments, periodic observations, or other methods of monitoring. Again, this is straight out of the Code of Federal Regulations. So, potential failure mode analyses. This has been required by FERC since December of 2002. It's to be conducted jointly by the owner, the independent consultant, and FERC staff. And a few definitions: a potential failure mode, PFM, is a chain of events leading to unsatisfactory performance of the dam or a portion thereof. The dam does not have to completely fail in the sense of a complete release of the impounded water. Failure modes that result in unintended releases of water, such as the Folsom Dam radial gate failure, are also considered. It's basically a scenario of chain of events that might lead to something that's unacceptable. Potential failure mode analysis, PFMA. This is the process utilized to determine the potential failure modes pertinent to the dam under investigation. And these definitions come from FERC documents, basically Chapter 14. So potential failure mode analyses, PFMA. The process is as follows. First of all, it's a consideration and development of PFMs. So this is an example of one. This example comes from the Best Practices in Dam and Levee Safety Risk Analysis, published by the United States Bureau of Reclamation and the Army Corps of Engineers. It involves an example of progression of internal erosion within a dam that leads to failure. So you start with initiation, and part of that initiation is the reservoir is at or above a threshold level. It means it's high. Initiation starts, that means erosion begins. It continues, so under continuation you have an unfiltered or inadequately filtered exit for the water. It progresses, you have a continuous stable roof or sidewalls. More progression, you have a constriction or upstream zone fails to limit the flows through the erosion. More progression, you have no self-healing by upstream zone. And again, toward the end, you have unsuccessful detection and intervention by the parties on site. And finally, this leads to a dam breach and uncontrolled release of water. These are all steps in a scenario that leads to a failure of a dam by internal erosion. So, along with developing the steps and development of the PFMs, you also identify more likely and less likely factors to affect that PFM. So a more likely factor could be something like the dam is subject to cracking because it has an irregular foundation. A less likely factor could be is that the dam was designed to have a good filter in it. It makes it less likely to erode. We have categorization of the PFMs into one of four categories: categories 1, 2, 3, or 4. And this is the standard PFM process outlined by FERC. The 4 categories are as follows. Category 1 is a highlighted potential failure mode. And these are potential failure modes that are of greatest significance considering the need for awareness, potential for occurrence, magnitude of consequence, and likelihood of adverse response. That's category 1. Category 2 is a potential failure mode considered to be possible, but is not highlighted. These are judged to be of lesser significance and likelihood. Category 3 is basically there's insufficient information to rate or evaluate the PFM, and there's additional information or analyses are needed. In category 4, the potential failure mode is ruled out because it's believed to be physically impossible to occur. So that's the standard rating in the PFMA process as outlined by FERC guidance. Along with the PFMA development and categorization is the consideration of uncertainties and also identification of potential risk reduction factors. These are the steps in a standard PFMA process that's required every 5 years.
Text, Congressional mandate.
Now, last fall, in September 2018, the U.S. Congress had a conference report, and this language was part of that. And this highlighted language in yellow basically says, FERC shall require the licensee of Oroville Dam, that'd be the Department of Water Resources, to request the United States Society on Dams to nominate independent consultants to prepare a Level 2 risk analysis consistent with Commission's guidelines for use in conducting the next Part 12 safety review of Oroville Dam, currently scheduled for 2019. FERC shall ensure the independence of the nominated consultants from the licensee. So this is a step above the standard PFMA process. So the 2 key things under this language in the legislation is that, first of all, it has to be done by independent consultants. And second of all, it has to be with a Level 2 risk analysis consistent with the Commission's guidelines.
Text, update.
So basically, instead of using the traditional categories 1, 2, 3, or 4, we are going to, under the Level 2, go to a semi-quantitative risk analysis, which uses a chart like this on the right, which looks at different consequences and likelihoods, actually estimates likelihoods as well as a range of consequences.
Text, overview.
So an overview of the ongoing Level 2 risk analysis.
Text, FERC summary.
FERC defines a Level 2 risk analysis as follows. It's periodic. Its purpose is to identification of all PFMs, prioritization of additional studies needed. It is the lowest level of risk analysis for decisions. It does a prioritization of inventory, and it also employs tolerable risk in evaluating existing conditions. The type of risk is mainly incremental life safety, but also economic. The typical level of effort is low to moderate, led by either a single individual, like an independent consultant, or a small team. The loadings are basic tools and methods estimate annual exceedance probability. The consequences are estimated by simplified methods, and the system response are common PFMs using simplified approaches, and the uncertainties are evaluated on a qualitative basis.
Text, FERC draft.
The guidance we're using is the one that's best available from FERC. This is their guidance for a Level 2 risk analysis. It's still in draft form. This is the second draft, version 1.1, published in June 2018, and this is what the team is using to carry out the risk analyses.
Text, purposes and benefits.
Purposes and benefits of a Level 2 risk analysis. Purposes include, first of all, it satisfies the congressional requirements for an independent Level 2 risk analysis. It also informs the FERC Part 12D periodic dam safety process, going beyond traditional PFMAs and category selection. Remember, the independent consultant still has to make their report, and they have to incorporate these results in it. Benefits include, first of all, it's an organizational learning opportunity for a lot of people. This is the first type of analysis that FERC has applied nationwide, and it'd be a great learning opportunity for all participants, including DWR. It will inform the DWR Comprehensive Needs Assessment and the Asset Management Program. It is a demonstration of a level 2 risk analysis on a major facility. And implementation of the independent forensic team's recommendation to expand the definition of failure, which is important. Organization, leadership, and participants. First of all, the risk analysis team leads were nominated by USSD and hired through HDR's engineering contract with the Department of Water Resources. The independent team participants include experts from over 9 different consulting firms and agencies that include Black & Veatch, Gannett Fleming, Geosyntec, HDR, LCI, Schnabel. It also includes the U.S. Corps of Engineers Risk Management Center personnel, and we reached all the way across to Australia from the University of New South Wales. That's the independent team. In addition to the independent team, there are DWR subject matter experts and contributors that provide design, construction, and performance information. They participate in discussions and initial rankings of risks, but not in the final independent evaluation. In addition, the 10th Part 12 independent consultant, Drs. Mejia and Bowles and Mr. Kennedy, they also participate in the discussions, but they do not vote on the risk determinations. Oversight is provided by FER staff and Division of Safety of Dams staff who are in attendance, as well as Eric Halpin, who's been hired to help oversee the process. He's the former chief of levee and dam safety for the United States Army Corps of Engineers. They participate in discussions but do not vote on the risk determinations. And finally, there are observers. These include the Comprehensive Needs Assessment Task Team leads and the Independent Review Board members, such as Dan Wade. They generally do not participate in discussions or vote on risk determinations, but observe the process. The risk analysis team leads and facilitators, these again were nominated by USSD and hired through HDR Engineering. Many of them are HDR employees or Gannett Fleming employees. Many of them used to work for the U.S. Bureau of Reclamation or the Corps of Engineers Risk Management Center and are very expert in risk processes, particularly for dams. The independent team developed a work plan for the Level 2 risk analysis and submitted that plan along with the participants to FERC for approval. FERC reviewed the plan and the proposed participants and sent a letter back to the Department of Water Resources on June 8th of this year, just about 3 months ago. And basically they concurred with the plan. Their statement is that we have reviewed the proposed plan and have the following comments. We agree with the broader interpretation and definition of failure as proposed in the plan. The proposed Level 2 risk analysis matrix is acceptable. The Level 2 risk analysis process described in the plan generally follows the FERC draft Level 2 risk analysis guidance and is acceptable. The generic Level 2 risk analysis report table of contents is acceptable. The proposed risk analysis team members identified in the plan are acceptable. These include the following consultants nominated by USSD. The independent team participants, these are the independent subject matter experts. They come from 9 different consulting firms and agencies. I won't read you all the names, but they have expertise in geotechnical engineering, civil and structural, geology and seismology, hydrology and hydraulics, and consequence analyses. And they come from all across the nation and, again, the University of New South Wales. DWR subject matter experts have similar expertise and are very familiar with the dam, and they're there to provide information and participate in discussions, but they are not part of the final independent evaluation. Oversight, again, is provided by FERC and Division of Safety Dam staff and Corps of Engineers staff, and again by Eric Halpin, the former Chief of Levee and Dam Safety for the Corps of Engineers. The 10th Part 12 independent consultant, again, that's Drs. Mejia and Bowles, Mr. Kennedy are there as well. And there are observers from the Comprehensive Needs Assessment Task Team leads and the project manager, and also Dan Wade is often there as well. And we have support staff. It's quite a planning effort for any session to get the right people there from the right expertise and bringing people from across the nation. In any one session, there's over 60 participants. The seating arrangement is generally to have the independent evaluators in the middle. That's the light blue and boxes in the middle there, surrounded by DWR subject matter experts and other contributors. And then in the outer ring or seats, there are facilitation team members, observers, and other contributors. We meet either in HDR's office or in hotel conference rooms. Again, there's over 60 people here. It's costing DWR over $100,000 a day to do this, and there are a lot of days. The process follows, again, the Level 2 guidance by FERC to take the existing information and develop an estimate of likelihood and consequences. The types of failures and consequences are divided into 4 groups, groups A, B, C, and D. The first thing is to think is, does the event occur? Does the component fail? So if it fails, is there life loss? If there's life loss, that's group A. If the component fails, and again, the component could be a radial gate or part of the embankment, but there's no life loss, that's group B. And then there are consequences even if everything works perfectly. For instance, in a very huge flood event, the reservoir in the dam will attenuate or reduce the flows discharged to the Feather River, but it doesn't stop them. And under some conditions, you still get flows that are overwhelming to downstream levees, even though the system works perfectly at Oroville, perfectly as intended, no component failure. In that case, you can still get life loss, that would be group C, even if everything works perfectly, or even if there's other non-life loss consequences, that would be group D. The type of semi-quantitative risk matrix, this is an example from the FERC guidance document that has different levels of consequences. In this case, what's in red is potential life loss. So in level 1, it's 0 to 1. Level 2 is 1 to 10 lives lost, and so on. Level 3, level 4 is 100 to 1,000. And then on the vertical axis is the likelihood, the annual likelihood that that could occur. And 10 to the minus 7 there is 1 in 10 million. The DBR's asset management risk matrix, that's the color-coded one in green, yellow, and red here. And that was developed generally for smaller components on the State Water Project. But for Oroville, the highest dam in the United States, we've had to extend the matrix just because the potential consequences are much greater than a typical component in the State Water Project. And so this is the risk matrix that is being used for level 2 for Oroville. It goes all the way up from, it starts with a potential life loss from 0 all the way up to greater than 10,000 and considers likelihoods all from 1 in 100 annual probability to 1 in 10 million. Potential failure modes. Prior to the workshop, potential failure modes identified in previous PFMA workshops from 2009 to 2014 were combined and put in a table, and then the participants prior to the workshops were asked to brainstorm new potential failure modes. And these were all combined into a matrix of identifying 171 pre-workshop potential failure modes were considered. These break down as 35 of them are associated with the embankments, 19 are associated with the emergency spillway, 64 are associated with the flood control outlet, the headworks, and the chute, and 53 are associated with the existing outlets. That's the Hyatt Power Plant, the Palermo Tunnel outlet, and the River Valve outlet. 171 total. Some of these PFMs were previously considered but not developed because they were not thought to lead to a breach or uncontrolled release. We're now looking at other consequences, so many of these are being developed now. And then during the workshop sessions, additional PFMs are developed and added to this matrix.
Text, process chart.
The basic process is to, in the workshops, is to present the available information relevant for the potential failure modes, do the steps in developing the potential failure modes, looking at likely and less likely factors, uncertainties, and then estimating the likelihood and the consequences. These will all go into reports that will be submitted to DWR and FERC later this year. Some of the, just a view, snapshots here. This is during one of the workshops involving the flood control outlet headworks. And these were looking at seismic issues. These are different potential failure modes being discussed involving different components of the FCO. This is the beginning of developing the steps in a potential failure mode. Remember the sequential initiation, continuation, progression. This particular one has to do with a potential failure of the mechanical system that lifts the gates. And during this process, the components are reviewed in detail. There's in the lower photograph there, you can barely see an outline of part of the hoisting mechanism. And the likelihoods are then estimated and the consequences are done using guidance from the FERC. And so far, we've done a lot of PFMs. Many of them were evaluated. Some were judged to be negligible and they were considered but not developed. So there's quite a few here just shown for the embankments and the FCO headworks. Again, so far we've concentrated on the potential for life loss, which is Group A. And in subsequent sessions, we'll be also looking at Group B, non-life loss consequences.
Text, schedule.
So our original schedule had us completing this by the end of March last month, but there is so much work for the highest dam in the nation, and so many potential failure modes, and so many people, and so much discussion that it's taking a bit longer than we thought. So we are adding additional weeks. This is the revised schedule on the right-hand side, and you see the additional weeks being added in red. And this will take us all the way to early August to complete the last planned session on the spillways. And with that, I'll say thank you.
Hello, I'm David Rennie. I'm Chief of Asset Management in the Division of Operations and Maintenance. Today I'm here to talk to you about the State Water Projects Asset Management Program, our risk management framework that is being adapted for the Comprehensive Needs Assessment, and how that risk framework feeds into our project planning and prioritization processes. First, a quick overview of the asset management program. Kind of the key drivers for this new asset management system that we're putting into place is kind of really starts with the recognition that the State Water Project has a very large and diverse, geographically dispersed portfolio of assets. Over 30 dams and storage facilities, 30 pumping and generating plants, over 700 miles of canal and pipeline that stretch from Northern California through the Central Valley to Southern California. The Division of Operations and Maintenance is not just an operator and maintainer of these facilities. We're also the program management organization for facilities that are placed into service. So there's an awful lot of coordination that needs to occur across a lot of different business lines. Also founded in this is the fact that while the program is relatively new, kicking off in 2014, asset management in the State Water Project is not a new concept. That actually began the day that the department was founded in 1956 and carried through from the planning, design, and construction of the State Water Project facilities to the current day operations, maintenance, and renewal activities. 2014 is kind of the important year for the O&M asset management program, because that coincides with the release of the ISO, International Standards Organization 55001 Asset Management System Standard, which is the first international standard for asset management systems. And we quickly adopted that standard as the framework for our program. Other drivers that are sending us down this journey include issues and risks associated with managing aging infrastructure, the inherent risks associated particularly with public safety and reliability for large, complex infrastructure systems. The complexity of what it takes to operate the State Water Project today is ever increasing, from new regulatory requirements, the stressors from the aging of the infrastructure, to changing needs from the customer base, customer demands, and climate change. Also recognizing the need to move the organization from a good tactical organization, the one that's looking out 5, 10, 20 years, developing longer term investment and resource plans, and finding that optimal balance between the operating and maintenance expenses and the capital expenditures or reinvestments into the infrastructure for the next 50 years. And wrapping all of that up with that large infrastructure base, developing an integrated approach to where the needs for these complex systems and the dams, the plants, the canals, and pipelines, how we can integrate the needs of planning and risk management across those different business areas.
Text, key elements.
So key elements of asset management that come out of this ISO 55001 framework is really creating a common framework for these diverse business lines. Creating what we like to call a line of sight between the organizational objectives, what the organization was established for, what services we intend to provide, understanding the stakeholder needs and expectations, and defining levels of service to ensure that we can meet those expectations, and then aligning our policies, our strategies, and plans, and delegating roles and responsibilities to ensure that the work done at the ground level on a daily basis is all in alignment with those core strategic objectives. Other key elements of an effective asset management system include effective monitoring of condition and performance of the asset portfolio, identifying and assessing, managing risks across this diverse portfolio, taking a life cycle approach to managing our assets. So we're not focused on just the least cost in the near term, but how managing the risks, the performance, and reliability of the portfolio of assets over the entire expected life of those facilities. The ISO standard also provides tools and a framework for establishing longer-term financial plans, so we can forecast and prioritize our resource needs, our expenditures, and prioritize our funding activities. Again, getting to that longer-term optimized capital versus O&M expenditure. And embedded in almost any ISO standard is the concept of continuous improvement. On the right, you see kind of a graphic of that shows how the ISO standard follows the simple plan, do, check, act cycle, where up at the top, the context and leadership sections of the standard, the planning and support kind of lay out all of the elements that you need in place to achieve the organizational goals. The operations section is the do part of the cycle, your performance evaluation. You're monitoring the performance and condition, not just of the assets themselves, but of the management system that supports them. In the check phase, and then making the adjustments based on those evaluations in a continuous improvement cycle, and on it goes. Overall, the ISO standard has 27 different elements that are kind of organized into these 7 categories, and over 180 specific requirements for an effective management system, and one that we adopted, like I said, back in 2014 when the standard was first published. One very key element there that follows in the planning and performance evaluation cycle is the concept of risk. When we think about that diverse portfolio of assets, the dams, the canals, the pipelines, the plants, the roads and bridges that we manage, each of those portfolios has a different set of risk drivers. Some assets like dams carry a lot of inherent risk to public safety and water supply impacts, where roads and bridges carry a different set of consequence. But a robust risk framework that allows you to score the issues associated with these various asset types allows you then to do relative comparisons and get an overall sense of not only what the risk profile looks for your portfolio of assets, but how the risk profiles vary from one group to another. We've accomplished this, and I like to say we've been able to use risk as a common currency across these different this diverse fleet of assets, by establishing a consistent definition and criteria that we can apply to the entire suite of assets. And what that allows you to do, you define risk as consistently as the likelihood of an event occurring times the consequence of it occurring. And you apply that consistently, you're able to then, as you see on the illustration here, you can plot the likelihood and consequence factors, I like to say, on the same sheet of music, and you can begin to see how the risks and issues associated with a canal section compares to that with a plant or that with a dam. And the other thing that you're able to then leverage from this type of an evaluation by driving that consistency across those different asset types is you're able to then select different risk-informed strategies based on where these dots land on the chart. Recognizing that how you might treat an issue that's a low likelihood, high consequence is very different than you would treat an issue like, a light bulb that may fail and burn out, that may be high likelihood but very low consequence. Able to pick different risk strategies. Obviously, if you move to the right, upper right of that screen, you'll see your high likelihood, high consequence. That's where you're probably going to be looking for risk mitigation opportunities to reduce the risk. Where you get to very low likelihood but still high consequence, you may not be able to find an engineering solution to reduce that risk, but there are a lot of strategies that you can employ for proactive condition monitoring and performance monitoring to make sure that you can detect issues as they develop before they become a real problem. And that can be just as effective, if not more effective, than attempting to mitigate the risk. So the risk framework that we've deployed, again, is really focused on trying to drive consistency across the business processes or business areas. We've based this on the ISO 31000 risk management standard. Our framework provides processes for risk identification, risk assessment, and selection of treatment options. It's also through the consistency we're able to evaluate risks at an asset or equipment level, aggregate them up to the facility and portfolio levels, and then inform our enterprise risk processes too. And where that becomes important is in the framework, it's not just about doing analyses and analyzing the risks. It's also setting up a framework to communicate those risk results to the appropriate levels internally, whether low likelihood, low consequence items are generally held and managed at the program level. As you move into the higher severity, higher likelihood, or higher risk areas, we have approaches to escalate those, the communication of those risks to division management, executive, and the appropriate external stakeholders. Another key facet is this risk framework builds upon a lot of risk management processes that were already in place across various O&M programs. A key tool then is the risk matrix, which I understand the ad hoc group has probably seen in the past. It's a 7x7 matrix, scoring based, likelihood on the vertical scale, increasing severity of consequence on the horizontal scale. For our AM processes, we score our issues across 7 different consequence criteria that are based on the SWP strategic plan. They focus on personnel and public safety, impacts to the mission, be it water supply, power generation, recreation, fish and wildlife enhancement, flood control, as well as financial impacts. This is really the tool that we build upon a number of different processes, from more detailed risk assessments, like you'll see in the next presentation for the comprehensive needs assessment. It's also been being incorporated into parts of the Oroville Level 2 risk assessment. And by adaptability, that means giving the different program areas the ability to fine-tune the resolution between the criteria and expand the range as necessary to capture and differentiate the risks that they're looking at that may not fit this 7x7 grid perfectly. But by the real benefit then of this risk framework is again driving that consistency across programs. So where we're evaluating things in a similar manner, we can compare likelihoods and consequences and risks across the dams, the civil features, the electrical and mechanical systems. And as I think you'll see on the next presentation, it's a building block for the comprehensive needs assessment risk activities. The other, I think, relevant risk-informed process that the ad hoc group is interested in then is when we do these risk assessments, we come up with issues that turn into proposed projects. We do have a risk-informed project planning and prioritization process that we incorporate into our near-term and longer-term planning cycles. And this planning tools incorporate three key inputs: the proposed cost of the project, the risk addressed by the project, and the internal resources required to perform the project. And for DWR, like many organizations, it's typically the internal resources that are the primary constraint on the being able to either perform the work internally or manage the work that's contracted out. So the resources generally become the greatest constraint that we try to balance through our prioritization process. We rely heavily then on our risk assessments to essentially assign a value to the project, with the prioritization process allowing us to identify those projects that reduce the greatest amount of risk in the least amount of time within the resource constraints that we have. Outputs of these planning processes then is a fully resource-loaded, risk-informed 2-year budget that we operate off of and update every year, as well as a risk-informed 5-year capital plan for these large capital programs that O&M manages. And when I say risk-informed, not every project is fully resource-loaded, so it's not fully optimized out to 5 years, but it gives a very clear picture of the types of major projects that we have down the road. And really that becomes the building or the plug-in piece for the types of proposed projects that are likely to come out of a program like the Comprehensive Needs Assessment. Come into this process, and those projects can be weighed against the risks and needs of the other parts of the State Water Project asset portfolio. So with that, I'd like to thank you for your time in this presentation, and I believe Dr. Ford will, in his presentation, show how the CNA is adapting that risk framework to develop the detailed risk assessments for their program and how that will feed back into our planning process.
Evaluation is really a key component of the comprehensive needs assessment, particularly evaluation of the existing risk at Oroville and the risk reduction that will be achievable by the measures and plans that are put forward by the comprehensive needs assessment. My name is David Ford. I'm from HDR. I'm a member of the Comprehensive Needs Assessment Integration Team, and I'm going to explain to you today the progress we've made on this evaluation step in the Comprehensive Needs Assessment. And also I'm going to remind you a little bit about what that process was. Here's a comment from the Independent Review Board in the last meeting. The IRB noted that they were pleased that the team had turned to DWR's asset management framework for assessing risk and for evaluating plans and measures in the Comprehensive Needs Assessment. They said that adapting this approach will be readily understood within DWR and has already had the benefit of considerable thinking and vetting through application, in addition to the other supporting reasons cited by the team. The IRB recommended that we develop the evaluation framework in the near term to include additional consequence or outcome categories, including beneficial project outcomes. I'm going to explain to you and give you a little detail of how we've taken this advice from the IRB to heart and move forward with it. Here's a summary of our progress since our last meeting. First, we devised alternative strategy to analyze risks for existing condition. My colleague Les Harder mentioned that a little bit earlier when he talked about the level 2 risk analysis and how that had been extended to account for consequences that were beyond what had been considered by the asset management framework, and also likelihoods or probabilities that were beyond what had been considered. I'll talk about that a little more in a minute. The second thing that we've done in the comprehensive needs assessment is to develop a workflow for our semi-quantitative risk analysis. And in these slides I've used this acronym SQRA a few times to represent that. The third thing that we've done that I'll report on is initiated the SQRA at the comprehensive needs analysis task level. That's become an important component. It relates to what my colleague Les Harder was talking about earlier with the level 2 risk analysis. I'll tell you what we've done and also explain to you why we've taken this strategy for the CNA. And then finally, we've continued our research on the best strategy for synthesizing results and applying multi-criteria decision analysis in the comprehensive needs assessment. We recognize that this is a broad-reaching project and that there are many criteria that need to be used to assess the performance of different measures that might be proposed, and we'll develop and use a multi-criteria decision analysis process for that. I'll talk about that a bit more in a few minutes. First, just a little bit of a review. Some of this relates to what Dan Wade was saying in an earlier presentation, and some relates to what Les Harder has reported, and also you'll hear about some of this from my colleague David Rennie. So first, our comprehensive needs analysis evaluation strategy builds on the Department of Water Resources risk-informed decision-making process for the operation and maintenance asset management. The figure on the right illustrates that. You've seen this before in other presentations. We've continued to ride the success of this in the comprehensive needs analysis. The axes on this show consequences on the x-axis and likelihood or probability on the y-axis, with the product of these being risk, and that's shown in the shaded boxes that are the central part of this diagram. Consequences here could mean any of a variety of different categories of consequences. There's life safety consequences, as Les mentioned, which are part of the level 2 risk analysis. There's also economic or physical consequences, environmental consequences, consequences in terms of delivery of the State Water Project. That broad range of consequences is being considered in the comprehensive needs analysis project. Les Harder mentioned in an earlier presentation that as a part of the level 2 risk analysis, but also as a part of the comprehensive needs analysis, we've extended or expanded this asset management risk framework matrix. In part, that's because we want to consider failure modes that have rarer or more rare, have a lower probability of occurrence, but we also want to consider failure modes that potentially have an impact that's greater than what had been considered originally in the asset management matrix. And so this cartoon on the right shows, as Les mentioned, that we've extended that downward and to the right. The next thing that we've done or that we do in the comprehensive needs analysis evaluation strategy is use that risk analysis framework from the asset management within this process that's illustrated by the figure on the right here. This process is the FERC FEMA process for dam safety risk analysis and risk management. And as you see, moving from the lower left to the upper right, it starts with a potential failure mode analysis, identification of those failure modes, and assessment of their likelihood, moving on then to risk assessment and use of that kind of information in terms of assessing risk of existing structures, but also in our case for the comprehensive needs analysis, using that failure mode analysis and the corresponding risk analysis to assess measures and alternatives that will be formulated as a part of the CNA planning process. I'll come back and talk about that a little bit because that's really an important consideration and an important piece of information about the progress we've made. And then finally, this slide here shows in the box on the right how we will use and consider various consequence categories and risk scores or risk ranks that are associated both with the without project condition, but with measures and alternatives that are formulated as a part of the CNA planning process. This is where the multi-criteria decision analysis that I mentioned earlier will fit into this entire CNA evaluation strategy and recommendations for actions that DWR will take moving forward in time. Let me return then to a conversation or some discussion of the potential failure modes, because that is critical and central to our evaluation strategy. You saw earlier in a presentation by Les Harder a description of what a potential failure mode is. Here's FERC's description or definition of a failure mode. They say it's a specific chain of events that lead to a dam failure. And FERC defines a dam failure as an uncontrolled release of water. This slide illustrates how we've extended that definition, in part because of recommendations from the independent forensic team and recommendations also from the independent review board for the CNA project. They suggested that we consider not just failures that would lead to an uncontrolled release of water, but they suggested that we use a definition much like the top part of this slide. That's a malfunction or abnormal operation that adversely affects the dam's ability to impound water and leads to something greater than a minor consequence, as defined by that asset management matrix that we saw earlier with the colorful boxes on it. That's the strategy that the CNA project team has adopted for our analysis. And so as we move through understanding the potential failure modes, the risk associated with them, that is the probability and the consequence, we're considering not just, for example, maximum loadings like the probable maximum flood or the maximum credible earthquake, but we're considering lesser loadings too, so that we can identify what the critical loading is on this system, and we can focus our efforts on remediating or mitigating the impacts that would come as a consequence of the occurrence of that event. We're not looking just at the biggest event. In fact, we're scaling our analysis all the way down to identify loadings for which there would be this minor or inconsequential consequence, and our plan formulation and evaluation carries through that entire range of events. The lower portion of this diagram or this slide illustrates that. You saw this earlier in a slide that Les Harder presented when he was talking about the level 2 risk analysis. I've included it here again because it fits right into and it's connected with what we're doing in the comprehensive needs analysis. That is, we're considering both component failures but also performing as intended when the consequence is worthy of consideration in the comprehensive needs analysis. Here's a timeline that shows our initial strategy for completing the comprehensive needs analysis. And in particular, I'll call your attention to the very lower portion of this, the box that's almost on the bottom of the slide, where it says Part 12D, PFMA, FERC Level 2 Risk Analysis. The original strategy for the comprehensive needs analysis was to leverage information that came from this Level 2 risk analysis to inform our plan formulation and to inform the measure formulation in individual tasks. So for example, our thought was, as we considered what we might do to improve performance of the low outlets and the Hyatt powerhouse, that we would consider information that came from the Level 2 risk analysis. So you see there a loop, if you will, one-way arrows of information coming forth from that Level 2 risk analysis to the CNA, so the CNA team could use that as we began to move forward with our plan formulation. I'll remind you with this slide of what the purposes and benefits of that Level 2 risk analysis was. You heard much of this earlier from Les Harder, but the key purpose was to satisfy congressional requirements and to inform the FERC Part 12D periodic dam safety process. So this Level 2 risk analysis was not being conducted specifically for the CNA. Instead, it was conducted as a part of the department's normal process of dam safety evaluation. The schedule for that Level 2 risk analysis, the original schedule, is shown on the left side of this slide. And so as you can see in that slide, that Level 2 risk analysis originally was planned to be completed late in March. The right side of this diagram shows the revised schedule for that analysis. As Les Harder mentioned in another presentation, that analysis has been extended because of the complexity of the Oroville complex, and also to gain the input from this broad and large group of subject matter experts that have been engaged by DWR to inform the Level 2 risk analysis, which then informs the Part 12D safety inspection. A key consideration here is that the process now, as revised, in particular with the spillways, will have potential failure mode analysis for that component going through mid-August, with reports out from all of this process following that some months later. Here's a schedule that shows what the CNA process schedule was. And if you refer to this schedule, you can see that the plan for evaluating and formulating measures for individual components of the Oroville complex, and then for formulating plans using those measures, had that formulation starting in June or July. And anyone who understands how calendars work realizes now that there's a bit of a discrepancy, if you will, between this original schedule, the CNA schedule, which we're bound and determined to stick to, and the Level 2 risk analysis schedule. Level 2 risk analysis schedule won't be completed until sometime in August. That trails the schedule for plan formulation and evaluation of the CNA by some months. And so as a consequence of that, the CNA integration team took a decision to engage in a preliminary potential failure mode using CNA team subject matter experts, many of which who had observed or been engaged in an informal way in the Level 2 risk analysis, to identify failure modes and understand the risk and consequence associated with those separately and independently for the comprehensive needs assessment. So this is a preliminary analysis that will be done to allow us to move forward with plan evaluation and formulation. At the end of this, then, we will, quote, circle back, unquote, to the Level 2 risk analysis to confirm that our understanding, and by our I mean the CNA team, understanding of failure modes and the risk associated with those is consistent with the Level 2 risk analysis. But this will permit us to move forward in a CNA workshop on existing conditions to formulate plans and to formulate and evaluate different measures that are appropriate for mitigating risk at the Oroville complex. So the CNA potential failure mode analysis is intended as a preliminary assessment of existing conditions to avoid further delays in the CNA project schedule. It makes use of the available Level 2 risk analysis results and products. It does that both through written communications and sharing of information, but also because many of the members of the CNA task team have been engaged in the Level 2 risk analysis as observers or providers of information. It utilizes the Level 2 risk analysis results as they become available, and as I said earlier, we'll circle back in the CNA process to the Level 2 analysis to use those results when they're completed. And key, at the end of both processes, we expect the results to be consistent with each other, and we certainly will make a comparison and understand any inconsistencies. Here's the process then that the CNA risk assessment is using, shown in a simple flow chart here. We, in our process, begin with a potential failure mode, but Here we're defining potential failure modes a little loosely because we're not considering just the maximum loading that could exist. As the loop in this chart between circle B and circle A shows, we're considering a broad range of loadings on the system. So for example, the spillway team is considering both the maximum loading, which would be the probable maximum flood, but it's also considering loadings that go downward to the standard project flood and even smaller loadings than that, so that we can understand the total probability associated with any broadly defined failures, and so we can understand the consequence of that. By doing that, we're able to complete a asset management like risk matrix such as that shown on the right side here. If you recall earlier slides where we looked at the asset management risk matrix, we had consequence along the y-axis, along the x-axis, we had probabilities along the y-axis. We've adopted that same strategy for the CNA so that in this illustration here we've considered 4 different loadings with smaller and smaller probabilities and greater consequences, and we've been able to assess the existing condition risk of that component of the project through that process, considering smaller loadings, evaluating the probability associated with those, and considering the consequences associated with each of those smaller loadings. If you think through this, you could realize that if we had, as Les was suggesting in an earlier discussion, several hundred potential failure modes, if we consider multiple loadings for each of those potential failure modes, we've got several hundred potential failure modes that we would assess as a part of the CNA. And that becomes a bit of a data management problem. And so to keep track of all of that information, which is critical to our decision making, we've created a database management application for this. And I have a few slides here that will illustrate how that's being used by the comprehensive needs assessment teams as they move through these potential failure modes, have a conversation about likelihood, consider the consequences that would result as an outcome from that failure mode. So first, this application, which all the teams have access to, has a typical Windows interface in which the teams provide text to describe the scenario that they're considering. So in this example, here's a potential failure of the emergency spillway monoliths due to head cutting through the reinforced concrete apron that's been placed during the recovery. The teams then walk through a set of dialogues that ask them to further describe that failure mode, to give information that comes forth from the subject matter experts on that team so that there's a record of their deliberations about likelihoods and potential consequences of this failure mode. The teams will also assess the likelihood and record that in terms of ranges of probability consistent with the level 2 risk analysis and also consistent with the analysis that's done as part of the asset management program by DWR Operation and Maintenance. And to do that then, they use this interface with radio buttons to identify their assessment of the likelihood of this potential failure mode. The text box below that provides an opportunity for the team to elaborate on their decisions or their considerations about probabilities of the sequence of events that lead to the failure. So in addition to the probability of the hydrologic or seismic load, they can here record their assessment of the probability of initiation of the failure mode, their probability estimate of the progression of that failure mode, their assessment of the probability of some successful intervention to prohibit the failure, and their assessment finally of the probability of the failure. And so you can see in this simple illustration here that the team has, if you will, walked themselves through the event tree or decision tree to identify those probabilities beyond just the probability of the hydrologic loading, which here was the probable maximum flood. As another step in this process then, the teams will identify the consequences. And the consequence identification uses the categories directly from the asset management risk framework, with categories defined and subcategories or choices within the categories defined through the work that the asset management group in operations and maintenance has accomplished here. So the comprehensive needs assessment team's process of identifying consequences is identical to that used by asset management. Here's an illustration of the interface where the team can select with these radio buttons their best estimate of the consequence. And in this case, as Les Harder mentioned in an earlier presentation, we have the ability to circle back and look in some cases at what the level 2 risk analysis has already accomplished in their deliberations. This goes through the entire set of consequence categories that asset management has identified. The first you saw was public safety and life loss. Here's a piece of the interface where the teams will identify their assessment of the consequence in terms of compliance. Here's reliability and flexibility of water delivery. Here's flexibility and reliability of other state water project purposes. That includes flood control, power generation, recreation, and other subcategories that are below this on the interface. And then we ask the teams, based on information available to them, to assess for each potential failure mode and each combination of loading in that potential failure mode, the financial impact. And so this is the financial impact to both the department, but also to others who are influenced by the outcome that would result from a failure, loosely defined here, not just maximum loading, but other loadings. Once the teams have completed the process of stepping through the potential failure mode and considering likelihoods and probabilities, then a diagram like this is produced that allows us to inspect the results for that potential failure mode, and then the team can circle on to other potential failure modes. Reports are available. These reports provide summaries of failure modes, loadings, and the consequence categories, both maximum and minimum and average categories that were identified through the CNA task team's analyses. Various summaries can be produced from this that enable the integration team then to quickly identify what the critical loadings were and to allow us with the task teams to focus on measures that are most likely to be fruitful in terms of risk reduction in all the categories that we've identified and talked about in earlier slides. So here are some ongoing activities then. We recognize that we're not finished. And so the next steps for the integration team are to develop a protocol for comparing without project risk with these many potential failure modes. We have, as Les Harder said earlier, hundreds of these failure modes. We've got to process these, identify which are critical, which we can identify actions or measures to reduce, and to begin to understand which of those are most critical and demand our immediate attention. Next, we have ongoing activities to develop a protocol for systematically evaluating risk with measures in place. The goal of the CNA is to decide what to do next. First, we have to understand what the current without project condition is, and then we have to understand what actions we might take will do to reduce that risk. And so that's the second step here. And then the third step related to that is to develop a systematic procedure for comparing first plans that we might take or measures that we might formulate, for example, to reduce the risk associated with the Hyatt power plant, and then to evaluate plans that would be formulated when we combine the Hyatt power plant measures, for example, with measures that will reduce risk associated with use of the spillways. Thank you.